Hello, and welcome to the first video of the Introduction to R course. My name is Philip, I'm a content creator at DataCamp, and I will help you take your first steps in this fascinating programming language. R, also called the Language for Statistical Computing, was developed by Ross Ayaka and Robert Gentleman at the University of Auckland in the 90s. It's considered an open source implementation of the S language, which was developed by John Chambers in the Bell Laboratories in the 80s. R provides a wide variety of statistical techniques and visualization capabilities. Another very important feature about R is that it's highly extensible. Because of this, and more importantly because R is open source, it actually was the vehicle to bring the power of S to a larger community. Like in every programming language, there are pros and cons. Because I like R, let's start with the pros first. First of all, it's open source, so it's free. Next, R's graphical capabilities are top-notch and it's very easy to build publication quality plots. In comparison to many other statistical software packages, R uses a command line interface, which means that you have to actually code things in your console and in scripts. While this might be frustrating at first, it makes your work reproducible. You can now rep your work in R scripts, which you can then easily share with your colleagues. Because of these advantages, R appeals to a large audience, both in academia and in business. Moreover, it's fairly easy to create R packages, which are extensions of R aimed at solving particular problems. R's very active community has created thousands of well-documented R packages for a very broad range of applications in the financial sector, healthcare, and for cutting-edge research. However, as with anything, there are also some disadvantages. R seems to be relatively easy to learn at first, but it's hard to really master it. Also, the fact that R is command-based is a frightening detail for statisticians that are used to the typical point-and-click programs out there. This steep learning curve sometimes results in poorly written R code that can be hard both to read and to maintain. Furthermore, poorly written R code can become slow if you're working with large datasets. But fear not, DataCamp is here to help you master R in no time. Use our courses to get a grip on R's fundamental concepts, and you can always consult R documentation for documentation on all publicly available R packages. Next up, your first steps in R. One of the most important components of R, and where most of the action happens, is the R console. In DataCamp's interactive exercises, the console will be your companion during your entire learning journey. It's a place where you can execute R commands. You simply type something at the prompt in the console, hit enter, and R interprets and executes your command. Let's start our experiments by having R do some basic arithmetic. We'll calculate the sum of 1 and 2. We simply type 1 plus 2 in the console and hit enter. R compiles what you typed, calculates the result, and prints that result as a numerical value. Now let's try to type some text in the console. We use double quotes for this. You can also simply type a number and hit enter. R understood your character string and numerical value, but simply printed that string and number as an output. This brings me to the first super important concept in R, the variable. A variable allows you to store a value or an object in R. You can then later use this variable's name to easily access the value or the object that is stored within this variable. You can use the less than sign followed by a dash to create a variable. Suppose the number 2 is the height of a rectangle. Let's assign this value 2 to a variable height. We type height less than sign dash 2. This time R does not print anything, because it assumes that you will be using this variable in the future. If we now simply type and execute height in the console, R returns 2. We can do a similar thing for the width of our imaginary rectangle. We assign a value 4 to a variable width. If we type width, we see that indeed it contains the value 4. As you're assigning variables in the R console, you're actually accumulating an R workspace. It's the place where variables and information is stored in R. You can access the objects in the workspace with the ls function. Simply type ls followed by empty parentheses and hit enter. This shows you a list of all the variables you have created in the R session. If you have followed all the examples up to now, you should see height and width. This tells you that there are 2 objects in your workspace at the moment. When you type height in the console, R looks for the variable height in the workspace, finds it, and prints the corresponding value. If, however, you try to print a non-existing variable, depth for example, R throws an error, because depth is not defined in a workspace and thus not found. The principle of accumulating a workspace through variable assignment makes these variables available for further use. Suppose you want to find out the area of our imaginary rectangle, which is height multiplied by width. Let's go ahead and type height asterisk width. Result is 8, as you'd expect. We can take it one step further and also assign the result of this calculation to a new variable, area. We again use the assignment operator. If you now type area, you'll see that it contains 8 as well. Inspecting the workspace again with ls shows that the workspace contains 3 objects now, area, height and width. Now this is all great, but what if you want to recalculate the area of your imaginary rectangle when the height is 3 and the width is 6? You'd have to reassign the variables width and height and then recalculate the area. That's quite some coding you have to redo, isn't it? This is the place where R scripts come in. An R script is a simple text file containing a collection of successive lines of R code that solve a particular task. When using R, you will build a lot of scripts to make things easier for you and hopefully automate parts of your work. We can create a new script, rectangle.r, that contains the code that we've written up to now. Next, you can run this script. Depending on the software you're using, there are several ways to do this. In the DataCamp interface, you simply have to hit the Submit Answer button to submit your script. In RStudio, R's most popular IDE, there's a Source button to run the script you're editing. In either case, R goes through your code, line by line, executing every command one by one, just as if you are manually typing each command in a console. The cool thing is that if you want to change some variables here and there, you can simply do this in the script, source your code again, and see how the output has changed. Let's change the height to 3 and the width to 6 and rerun the script. This is the true power of reproducibility at work here. This also makes sharing your scripts very easy. You just send your R file and the recipient can simply run it on his or her own system. However, you'll sometimes have to help people understand what you've written and clarify your code here and there. You can use comments for this, which are lines of code that start with a pound sign, like this one. Let's extend the script with some more information. We add 3 lines of comments, one line before the assignment of height and width, another one before the calculation of area, and the last one just before the printout of area. If you would run the script again, the lines starting with the pound sign do not affect R's execution. But beware, perfectly valid R code that you place behind the comment sign is interpreted as a comment and won't be considered by R. Let's have a final look at the workspace. As before, there are 3 variables in your workspace: area, height and width. If you're working on big projects that have tons of data involved, this workspace can consume a lot of your computer's resources. It's a good idea to clean up your workspace from time to time to make sure it does not get bloated. You can use the rm function for this. To remove the area variable, for example, you can type rm followed by area inside parentheses. If you now check your workspace again, using ls, you will see that only height and width remain. Trying to access the contents of area now results in an error, because it's no longer in your workspace. Now it's time for some interactive exercises. Try to solve the different instructions and let DataCamp's tailored feedback guide you to R mastery.